I had this question. I was looking at light bulbs and I got lumens versus candelas, and I was like, what are these two things?
Yeah, I'm also confused by this because I don't really know what a lumen is, and apparently a candela is a standard base unit, and I was like, what?
Okay.
What?
Okay. So I
I'm
guess,
shocked.
well, the questions I have is what is a lumen and why is it chosen as a base unit? Can you explain to me what is a base unit? I didn't understand what that was.
So I think there's seven base units, and
Okay.
those units are not derived from any other units, and they build up all the other units that we use to measure things in the world.
Oh,
So,
it's
for
like,
example, I think a meter is a base unit,
yeah,
and then if you want to do volume, we do meter cubed to make a
I
cube,
see.
and that's our volume. So meter is the base unit, and volume, meters cubed, is a derived unit.
I see. So if I had like miles per hour or meters per second for speed, those are not base
Yep,
units because they're made of other stuff.
that's right.
The base units are like oh, there it is. It's the base unit. It's like the fundamental
Right.
bit.
So it's shocking to me that a candela is a base unit because to me it feels derivable. It's like an intensity of light in, incident on an area. That's what it feels like to me. Or like a power of light incident on an area,
Okay.
something like that, which
Uh,
totally feels derived from other things. So how is it a
hmm.
base unit? What?
Okay. I don't know. But maybe we can figure out what these things are. And can we start with lumen first? Because that's what I happen
That's
to look up.
that's
Okay.
okay.
Let's do lumen, then candela. So here is a lumen on Wikipedia.
Yep.
So the lumens symbol is an LM. It's the SI
Mhm.
unit of luminous flux, which quantifies the perceived power of visible light emitted by a source.
Okay.
So it's not just the light, it's the perceived power. But it's not just
Okay.
power, which is like energy out in per second in every direction.
hmm
It's the perceived power.
hmm
Okay.
So
Okay.
it sounds like a weird unit because it's taking the sensor into account.
The
In
sensor.
this case, the human eye. It's weird, I think, to put the sensitivity of the sensor into the unit itself, which is kind of weird. But I think
Uh,
we do this because it makes like reading gauges out in the field easy.
okay.
So if I want to know, can I see the star? It's nice to have a unit that corresponds to me seeing the star.
Oh, okay. And if a star is brighter, and I see that it's brighter, then the scale on my detector also goes up.
Yep.
Okay.
So I think it's for
Whereas
convenience.
whereas if you decouple the perception aspect of the unit, then your eye might see something go really bright, but then the gauge may not see it because like it doesn't depend on your brightness, your eye. You build a
Right.
natural unit, which feels weird because it's your perception, your eyeballs built into it, but actually feels right because that's how you perceive the world.
Yeah.
Okay, let's continue reading.
Okay.
Luminous flux differs from power, radiant flux, which encompasses all electromagnetic waves emitted, including non-visible ones such as thermal radiation, infrared. Okay.
Okay.
So power in general is like even wavelengths that you can't see. So if you turn off the lights, but there's something that's hot, like a frying pan, whatever. If you have a
Yep.
thermal camera, you'll see it, but your eyes don't see it. And so luminous flux, which is part of what like you see, like it was
Yep.
light that you see, needs to account for, or needs to only account for the parts of the stuff that you can see, like only the visible spectrum stuff. Why are we counting stuff that
Right. Right.
humans
So,
can't see?
so say turn off the lights in a room
Uh
where
huh.
there's something hot in the room.
Uh huh.
Then the luminous flux is zero because it's dark,
Yep.
but the radiant flux is non-zero because that device, that hot thing, is emitting a lot of IR.
Right. It is radiating. It's just in the
hmm
infrared, which my human eye can't see.
Right. Okay, so I'm super happy with the lumen in that it's a radiant flux, which is power per area, I think,
Okay.
of light. Then it's normalized or multiplied by the sensitivity of the sensor.
Your human
Super
eye.
happy with that.
Yeah, okay.
That feels super derived. So then, what the hell is this Candela thing? How is that not radiant flux? I guess there's Candela.
Okay. So maybe does it come up here? The
Let's see.
lumen is defined as the equivalent to one candela steradian is one candela. So it's a candela times a steradian. Steradian is like a solid angle. So not only an angle
Yeah.
in this direction, but if you
Yeah.
spin it around in a circle, it's like a cone that comes out.
Okay. That is
Okay.
a weird way to define that. What?
Well, that's right because if you have some brightness, but then you're further away, the intensity should get lower because you're further away. Like the cone gets bigger and bigger and bigger.
Okay.
So it's trying to
So,
like account for the distance away that you are from the whatever the bright object is.
okay.
Maybe the explanation gets it.
Okay.
Explanation. If a light source emits 1 candela of luminous intensity uniformly across a solid angle of 1 steradian, the total
Mm-hmm.
luminous flux emitted into the angle is 1 lumen. Okay, I think we need to get
Yeah.
candela, or otherwise,
Yeah. Yeah.
okay. Otherwise,
Okay.
we're yeah. So candela, CD is the SI unit of luminous intensity. Oh my gosh, it's like folding on itself. It
Yeah.
measures the luminous power per unit solid angle emitted in a particular direction. A common wax candle has luminous intensity of approximately 1 candela.
Okay. So somehow it's
Candela
like
from Latin.
if I have a uniformly emitting source, then as I go farther away from the source,
Mm-hmm.
the candela doesn't change. Because as the perceived brightness of the source goes down as I get farther away, that's only because the area of my sensor is going down
Yeah.
relative to the emitted power. This is a weird way to define it, but okay.
No, but it's right. It is weird, but it's right. Because if you have a candle burning and it's right next to your eye, super bright.
Yeah.
But if you
Super bright.
leave that same candle and it's just burning, but you walk across the street, it's super dim. But it's not because
Yeah.
the candle is not burning as bright. Like it's still doing its thing. You are farther away, and so your iris, or I guess your pupil is just a smaller circle relative to the distance.
Yeah.
So we make this candela to say, well, you have to account for the cone that's coming out,
Okay.
like the solid angle, the cone that's reaching you.
Okay.
However,
I'm super happy with this. It's like it's a amount of energy
uh-huh.
that's inside the electromagnetic waves being emitted by a source, and it doesn't care about distance. It just wants to know how much is that source emitting.
Yeah.
Okay, I'm happy with that.
So
To me, that still feels like a very derived unit, like an energy per of a source, like or power of a source. Right? How is that? I think it has in the definition here. It redefined the candela. It's down here under the definition.
definition. This thing? The candela is defined by taking a fixed numerical value of the luminous efficacy of a monochromatic radiation frequency of this thing, K sub CD, to be 683 when expressed in the units of luminosity per watt, which is equal to candela steradian per watt. Or, oh my gosh, okay, candela steradian per kilogram meter squared seconds cubed, where the kilogram meter second squared are different in terms of this thing. Oh my gosh.
Yeah.
Okay,
So
this is almost
what?
this is a joule per second. They took watt and they turned it into a joule per second.
Okay.
Okay.
Because a watt is a joule per second, so it's kilograms meters squared per second squared. Oh, and then you flip it. Got it.
Flip it. Yep,
And then
flip it.
a candela times a steradian
Oh my goodness.
is an energy.
I think it's energy.
But what?
Because it's gotta end up as being a energy per second per area.
Right.
Because it's gotta end up
But
being a power.
But I
per
think the
sec- per area.
candela is a base unit, so
Power
you
per
can't
angle.
define the candela as a power per second per area, or per steradian.
Per angle, yeah. Per angle area, which is unitless, yeah.
Yeah. So you got to flip it all around and do
Yeah.
it the other way.
Yeah.
So it's like, why did they do this?
Ooh.
Could we look up the SI base units? There's like the new list. There it is.
International SI
What is
units, 7 base units, second, meter, kilogram, ampere, Kelvin, mole, candela.
So shouldn't I be able to derive the candela from seconds, meters, and kilograms? The candela is a power per second per steradian. Power is
Yeah.
kilogram meters per square meter squared second squared
Kilogram, meter per second squared.
per second.
Yeah.
Which is second.
Yep.
And then a steradian is unitless.
Yep.
So how is candela not derived
Yeah,
from SM
I
kilograms.
feel like you're
What?
going on anti-Pluto rage here. We're gonna get it kicked out of the club.
Well, yeah, I
Okay.
guess they put this the SI people.
Uh-huh.
They put it in there for a reason, and I don't understand why.
I think okay, but it is different. Even though the dimensionality is like kilograms, meters, and seconds, and because even though angles are dimensionless, it is a physically different quantity because of that per angle ness.
But if I were to say that candle over there, what's it emitting? And you would say, oh, it's emitting, a total of 5 watts. You'd be like, it's emitting Candela. A watt is a derived unit. A Candela
Uh,
is like I want it to be watts. The
okay,
total energy
okay.
of
No. You phrased a bait question. Because if you were to ask me how much energy per second is it emitting, how much power it is emitting, I would answer you in watts because that's the unit like that you're asking for,
yeah,
like the quantity you're asking for. If I were to ask you
yeah.
how bright is that candle, then it's in candela
Okay, how are those not the same thing?
because the brightness is built into your perception. Like it's a light verb, it's a light noun as opposed to a power noun. Power noun brought to
Okay,
you
but
by
somehow the
Candela.
Candela doesn't take into account the sensor. So it's somehow then how is it not like a photon count from the candle?
I think that is.
It's emitting a trillion photons per second with some distribution.
Trillion photons per second is a power because there's an energy. Then you divide by the energy per photon, and then you now photon per second. So that's
That
a different type of. It's like a number power. But what we want is a perceived number power that enters your eye, which now considers like the angle.
Okay,